Evaluating analysis results is an essential part of being an engineer. The best way to do that is to predict results. When I say predict results, I don't mean make a guess. Experienced engineers make simplified calculations to get a sense of the answer, or they make qualitative assessments to identify features of the answer. They use those results to evaluate their lengthy hand calculation results or their computer-aided analysis results. The key is to make these simplified calculations and qualitative assessments before performing the detailed calculations. There are several reasons why. The first reason experienced engineers start with simplified calculations is practical. Detailed analysis, like the methods we learn in later chapters and what is used in computer-aided analysis, requires material and section properties. But to choose the material and section properties, we need to know the internal forces. To obtain the internal forces, we need to perform structural analysis. To perform structural analysis, we need to know the material and section properties. Do you see the circular logic problem? Approximate analysis lets us obtain internal forces without knowing the material and section properties. We can then use those internal forces to make initial selections of the material and section properties for detailed analysis. Structural design is an iterative process. Select properties, perform the analysis, obtain internal forces, select new properties, reperform the analysis, obtain new internal forces, select newer properties. You get the idea. The better our initial selection of properties, the faster the design process converges. The most powerful reasons to start with predicting results come from cognitive psychology. There are two phenomena that drive why it is so important to start by predicting results. The first phenomenon is inconsistency discounting. Psychologists have observed that when humans are presented with two pieces of information that conflict, that don't agree, we tend to trust the first one we receive more. For example, if I gave you an article that says the force method, which we cover in a later chapter, is faster than the moment distribution method, then I give you an article that says the moment distribution method is faster than the force method, you will tend to believe that the force method is faster. But if we switch which article you read first, you would tend to believe that the moment distribution method is faster. This is human nature. Rather than trying to fight our own nature, we can learn to work with it. I'm going to perform a simplified analysis and a detailed analysis. Which do I want to trust more? The one that is less accurate but also less prone to errors, or the one that is more accurate but more prone to errors? Experienced engineers want to trust the one less prone to errors more, so they start with the simplified analysis or qualitative assessment. The second phenomenon is confirmation bias. We want our detailed analysis results to be reasonable, so we tend to look for aspects of the results that are reasonable. Unless we are looking at the totally wrong structure, our computer-aided analysis results are going to have lots of reasonable features. Our job is to find any unreasonable features. Computer-aided analysis creates a huge amount of results, even for a very simple structure. There are internal forces and deformations at each end of every piece of the structure. If we are working with a three-dimensional model, that is 12 pieces of information at each end of each piece. Do you see how we can reach data overload? To avoid confirmation bias that is made worse by data overload, experienced engineers start with simplified calculations and qualitative assessments. They then check those aspects of the detailed analysis results. By using this approach, we are checking specific things in our detailed results regardless of how they look. Plus, the things we calculate in our simplified analysis will tend to be the most important quantities, so we are making sure to check the most important results.